Yeah, good evening friends. In this video, I am going to compare 2D versus 3D mohr circle. What is the difference between 2D and 3D mohr circle? How to calculate? What are the fundamentals in the 2D versus 3D mohr circle? Now I am going to discuss in this video. Okay, let us take what is mohr circle. Mohr circle is a graphical representation to find our required stresses. Okay, and these things you have to keep in your mind while drawing a mohr circle. The second point is, while in an element you are having planes, and those planes will become points in mohr circle. Okay, and then if you rotate our element, if you rotate our plane in that element with theta degrees, then it is rotated to 2 theta degrees in mohr. Okay, as a graphical representation you have to follow these things in your mind. Okay, now let me continue my video with the 2D analysis. Okay, now let us take a body, two-dimensional body. This is my two-dimensional body, and I am having along x direction my load is px. This is body, keep in your mind, this is body. Okay, this is my py, this is my py. Okay, as a body you are having forces. As it is a bidirectional, your every element in the body is critical. Okay, now let us take an element here. Okay, this is my element. I am taking a small element here. Okay, on element you are having stresses sigma y, shears tau xy, tau xy. Okay, this is the thing you have to follow. Now for this, let us take, this is a reference plane. It depends upon you. You can take anything as a reference plane. This is the plane A, this is the plane B, and it is having 90 degrees in the element. Okay, and this is my reference plane A, this is my plane B. This is reference plane as I am taking here. Okay, this is my reference plane. Now, how to calculate center in 3D mohr circle? How to calculate center? Sigma x plus sigma y by 2 comma 0. This is my center, and then what is my radius? Radius is equal to root of sigma x minus sigma y by 2 whole square plus tau xy square. This is my radius. Okay, on getting center and radius you can continue your mohr circle. Okay, then as this is my element, okay, having x and y axis, if I rotate this element to theta degrees, okay, I am rotating this element, this is y dash and this is x dash, I am rotating this element into theta degrees. Now if you are having an oblique plane here, on this oblique plane you are having, on this oblique plane I am drawing again here, see, on that oblique plane I am having, this is my theta, I am having a normal stress and a shear stress, tau. Your main motto is to find this normal stress and shear along with the principal stresses graphically by mohr circle. Now you can find that principal stresses by analytical method also. How to find? Sigma 1 comma sigma 2. These things you may know. Let me say once again. Okay, sigma 1 plus sigma x plus sigma y by 2 plus or minus root of sigma x minus sigma y by 2 whole square plus tau xy square. By this way you can find our maximum and minimum principal stresses by analytical method. If you want to find the same things with graphical method, you have to follow a mohr circle. Okay, I have drawn my mohr circle. I have solved a problem in the next video of how to draw a 2D mohr circle having a center, this and radius. Okay, like this you can find. As see here, this is my reference plane A. Okay, and then the reference plane is making an angle theta degrees with our oblique plane. Then the same angle in my Mohr circle means the angle between reference plane A and oblique plane here is theta. In my Mohr circle it is 2 theta. Okay, these things you have to keep in your mind. Okay, 1, 2, 3. These 3 points are very important. You can follow. Now I am going to discuss how to calculate the 3D Mohr, how to construct a 3D Mohr circle. Okay, let us see here. If you take 3D Mohr circle, if you take a 3D Mohr circle, okay, 3D. Now I am discussing now I am discussing about the 3D Mohr circle. Okay, let us take a 3D element. No, 3D body. It is not a 3D element. Okay, this is my 3D body. Okay, I am having px of load, my px, py, this is my py, and I am having pz. Okay, as the every element is critical here, let us take a small element from that. Okay, this is my element. I am taking this element. Okay, this is my element, and this is sigma x. You are going to get a stress tensor here. Okay, sigma y, sigma z. Okay, this is my shear. Okay, this is my shear. Okay, these are the shears. Tau xy. It depends upon the stress tensor depending upon your direction, as you already know. I am not discussing about the stress tensor. Okay, you are having it in order to calculate. You should have a stress tensor sigma xx, tau xy, tau xz. Now sigma yy, sigma zz. Okay, this is tau yx, tau yz, tau zx, tau zy. Okay, this stress tensor you have to follow here. Okay, now how to calculate 3 stresses in 3 principal stresses. Okay, you have as a 3 by 3 matrix, you will get a quadratic equation, sigma cube minus I1 sigma square minus I2 plus I2 sigma minus I3 is equal to 0. I1, I2, I3 are stress invariants. Whatever may be your conditions, this I1, I2, I3 value won't change. Okay, these are the constant values. Okay, then how to calculate I1? Okay, I1 is equal to sigma xx plus sigma yy plus sigma zz. This is my I1. I2 is equal to det. See, this is my det. Okay, sigma xx, tau xy, tau yx, sigma yy plus det. Sigma yy, tau yz, tau zy, sigma zz plus det. Okay, sigma xx, tau xz, tau zx, sigma zz. Okay, on having some practice it will easy, don't feel more clumsy. Okay, now I am taking the total stress tensor as my det, sigma xx, tau xy, tau xz, tau yx, tau yy, tau yz, then tau zx, tau zy, sigma zz. Okay, if you calculate these things, you will get I1, I2, I3. If you substitute in the equation 1 these I1, I3 values, you will get a quadratic equation. On solving that quadratic equation, you will get 3 roots. Those 3 roots are sigma 1, sigma 2 and sigma 3. Okay, in that sigma 1 is greater than sigma 2 is greater than sigma 3. Okay, sigma 1 is greater than sigma 2 is greater than sigma 3. This is my maximum principal stress, this is second, and this is the third one. Okay, this is the way you have to calculate the 3 principal stresses. Okay, if you take an oblique plane, as this is our element, okay, and this is our element. If you take this element, this is our element. You are having sigma x, sigma y, sigma z, and principles also, sigma y, sigma z, and you are having principles also, shears also. Okay, in this oblique plane you are having a normal and a shear. Okay, in this oblique plane you are having a normal vector. This oblique plane, every oblique plane having a normal vector L, M, N. Depending upon this normal vector, you have to find directional cosines in sigma 1, sigma 2, sigma 3. Then you can construct our 3D Mohr circle easily. This thing also I have discussed in my next video, how to draw a 3D Mohr circle. Okay, by these things you can easily find, and you can compare what is 2D, what is 3D, what is the how you can proceed, how to solve. Okay, these are the things you have to keep in your mind, to how to construct a 2D Mohr circle, how to construct a 3D Mohr circle. These things may be clumsy, but you have to get some practice so that you can easily follow the things. Okay, thank you.